A radical expression is considered simplified if the following things are true. The radicand, which is the number underneath the radical sign, so the thing in the square root, okay, the number. If the radicand has no perfect square factors other than 1. So if the number can still be divided by 4, for example, which would be the smallest possible perfect square, then you've not gone far enough. You need to keep going. The radicand contains no fractions, and no radicals appear in the denominator of a fraction. So we do not want square roots in the bottom of a fraction. Wasn't my idea, but we don't allow that in math, and so we'll talk about how to get rid of that later, not today. Okay. Simplifying radicals by removing perfect square factors. First one we're going to look at is 45. 9 and 5. So I'm going to break this up. Square root of 9 times 5. I'm saying the same thing. Then we break it up into 2 square roots. So this is the same thing as the square root of 9 times the square root of 5. I'm still just saying the same thing a different way. What is the square root of 9?
33.
So we write this as 3 times the square root of 5. But when we write this, we normally don't put that multiplication symbol in there. So if you've got a pencil, this will work out well for you. But we would write it as 3 root 5. So with no multiplication in between. So hopefully you see the linear effect here. Everything, we're saying the same thing. So you're going to end up with a number outside of it. It's just being multiplied by the square root of 5. Check it. Can square root of 5 be divided by any other perfect squares? 1, and that's it. So you're done. So I'm going to move that 3 over a little bit further. Okay. Next one, we already talked about the square root of 200 a little bit. You don't want to break it up into 25 and 8. You could. You'll have to break it up multiple times, and that's fine. But the biggest possible perfect square is what again? 100. So we're going to break this up into 100 and 2. So square root of 100 times 2. And we can write that as 2 square roots. The square root of 100 times the square root of 2. Guys, what's the square root of 100?
10.
Yay. So it's 10 root 2. See, that kind of fun? Please discuss what is the largest possible perfect square factor. 25. So notice how I keep putting this perfect square first. That's because I'm going to take the square root of the perfect square outside of the radical. So square root of 25 times 2, what's the square root of 25? Hold on, I got ahead of myself. Square root of 25 times the square root of 2. Square root of 25 is 5, so it's going to be 5 root 2. And then you check it. 2 cannot be broken up any further. I have pencils at the front. Go through a few, okay? Perfect square variables. I'm going to use x. So just like we did on there, what is x times x? X squared. So, hold on, I got to move this over. X times x is x squared. So what is the square root of x squared? Okay, good. How about x squared times x squared? X to the 4th. Someone please tell me why. Catherine? Yep. Last semester we talked about add the exponents. So we're just adding these exponents up. Okay. And so the square root of x to the 4th would be what? X squared. So we can keep going. Hopefully you get the hang of it. X third times x to the 3rd would be Yep, x to the 6th. So the square root of x to the 6th is x to the 3rd. We'll just do one more. X to the 4th times x to the 4th is x to the 8th. So the square root of x to the 8th is x to the 4th. What do you notice is happening over here? Like, what's a quick way you can know right away to get the square roots of variables with exponents? Aaron?
Half.
Yep. It's going to be half. So the square root of x to the 4th is x squared. So just have that variable, but you could also just think to yourself, I'm adding up two variables to get that. So you're looking for even variables. So if you have a variable to an even exponent, you should be able to take the square root of that. So if you have something like x to the 9th, we can break it up into x to the 8th and x to the 1st and take the square root of the x to the 8th. We'll do that. All right, x squared, we already did that. What is it? Yeah. Done. How about g to the 4th? G to the 2nd. Okay. Now this is what I'm talking about. X to the 7th is an odd number. And I'll be like, I can't do it. And then just move on. No. Remember, we can break it up. So what should I break this up into? Please tell the person closest to you. Oh, Mira, what should I do? Uh-huh. So x to the 6th times, you could put x to the 1st or just x. It doesn't really matter. I'll put x to the 1st. So remember, all we did is, since we can add these exponents, we just broke it up. And now we're going to break it up into the square root of x to the 6th times the square root of x to the 1st, or just x. What's the square root of x to the 6th? 3rd. X to the 3rd. And then you still have x. This is an odd number exponent, and so you can't do anything with it because it's down to 1. You're done. Now you've got a number and variable. So we want to break this up. Square root of 25 times v to the 5th. All right. Take your best guess of what you think would be. Tell your partner. Okay. So I'm going to break this up into number and variable. So I'm going to break it up into the square root of 25 times the square root of v to the 5th. I'm going to start with that. What's the square root of 25? 5. Okay, so you've already done one thing to simplify it. But you've got that pesky variable in there. So remember, we're looking for even numbered exponents. So can someone explain to me, what should I break this up into, Southwick?
V to the 4th times v to the 9th.
Uh-huh. V to the 4th times, I'm just going to put v, but that means v to the 1st. And now, what is the square root of v to the 4th? V second. V to the 2nd. So 5v to the 2nd times square root of v. Finn, were you saying that, could you just break it up into v squared, like that? No? Okay. Let's break it up into numbers and variables. So I'm going to do the square root of 18 times the square root of x to the 4th times the square root of y to the 3rd. One piece at a time. Let's start with the number. Tell the person closest to you, what's the largest possible perfect square that 18 can be divided by? It's 9. So we're going to break this one up into the square root of 9 times the square root of 2. Okay. Let's keep going with the variables, because I think we can do this. We can do this one, right? What's the square root of x to the 4th? So x squared or x to the second, both are correct. And then you've got x to the third. Sorry, that's what I meant. Y to the third, yes. So we would break that up into y to the second times the square root of y. Let's simplify as much as we can from this. So you've got square root of 9 is, okay, times the square root of 2 times x squared. What's the square root of y squared? Y times the square root of y. Do you think we should leave it like this?
No.
Certainly not. All of the things that are out of the square roots you need to put in front. Number goes first, followed by the variables, usually in alphabetical order. So this is, the final answer should be 3x squared y times the square root of, you can put the 2 and the y back together, and you should. So it should be 2y underneath the square root. If you'd rather like keep this all underneath one giant square root, you could do that. I personally don't like doing that, but it's up to you.
Cool and good.
That's legit.
Remember, everything outside the square root goes in front, alphabetical order, A, B, C, D, E, F, G, H. Okay. Oh, I'd put G to the H. And inside the square root, put in alphabetical order as well.